So we're gonna start by eliminating. So D2 here, which is x2. In order for us to eliminate, we are going to multiply the first equation with d minus 2, d minus 2 minus d, equation 1. So we're going to multiply equation 1 with 2 minus d, and we also going to multiply equation 2 with 2d. So in order for us to do that, when we multiply this equation 2 with 2d, we're going to have 2d d squared plus 1. This is x1 minus 2d, and then 2 minus d again. This is the side of x2, which is equals to 2. This is 2t. Then it's going to be 2t. So with 2t, we can just work it out same time. So 2t with d, 2t is going to give us the first one is going to give us 4. Multiply by this 2 here, it's gonna be 4t. Then when we differentiate, this one is gonna be minus 2. So we can make this to be equation 3. Then equation 2, we multiply with 2d. We will have 2d minus 1. This is the side of x, 1 minus 2d again, d not d is 2 minus d. Then when we differentiate this one, it's going to give us 0. This is going to be question 4. So now we have equation 3 and equation 4. So what we can do now, we can, if we add them, we can subtract equation 1, equation 3 minus equation 4. So if we say equation 3 minus equation 4, we are going to be left with this one. We can just multiply it back. It can give us 2. It's gonna say 2d squared plus 2. This 2 times 2d and 2 times 1, and d minus this one is gonna be minus d cubic minus d. Then minus this one times this one is gonna be 4 d squared minus 2d. Everything there, we know that is going to be the side of x1, which is going to be equals to this one minus this one is going to give us 0. Then we're going to have 4 equals to 40 minus.
How did you get minus 4d squared?
Which one? This one here.
Yes.
This one, 2d times 2 is going to give us, oh, so let me check something, not this one here. Is it, we have this one here, 2d times 2d. This one times this one, it will give us 4 d squared. Is it,
Oh,
we are
okay.
saying equation 3
Understand.
minus equation 4. Then 2d times minus 1 is going to give us minus 2d. Or you get it now? Remember our formula is saying equation 3 minus equation what? Equation 4. This negative here is this negative here. So 4t minus 2 minus 0 is going to give us this one. Then here now we can just group the like terms. When we group the like terms, you will see that here we will have minus d cubic. Then this one is going to be minus 4d. And here we have positive 4d. We're going to have minus 2d squared. And we also have plus 2d and minus this d is going to be plus d. Then we will have also only plus 2. So now when we have this, we can now factorize this one. This one, if we factorize, we can rewrite it as m cubic minus 2m squared plus m plus 2, which we can make it equals to 0. So if we do that, we will see that we can even rewrite it as, we can take out the negative. If we take out the negative, we're going to be left with m cubic plus 2m squared minus m minus 2 equals to 0. Then we multiply by negative 1 both sides. We're going to left with m cubic plus 2m squared minus m minus 2 equals to 0. Then now we can try to check a number that we can use so that we can get 0. If we use m here, if we use m, if we let m, if m equals to 1, you will see that if we substitute 1 in this equation, we won't have 1 cubic plus 2 brackets 1 minus 1 minus 2, which is going to give us exactly 0. Then now we know that m, when we take 1 the other side minus 1, it's a factor. M minus 1 is a factor. Then we're going to use a long division to get the other remaining values. M squared m cubic plus 2m squared minus m minus 2. So m cubic divided by m going to be m squared. M squared will multiply back by m is going to be m cubic. M squared times negative 1 is going to be minus m squared. Underline, you multiply by negative. Then this is going to be negative, is going to be 0 when you add those two. Plus this one is going to give us 3. M is going to be positive plus 2m squared, 3m squared minus m, which is this one, and minus 2. Then we divide by m again, we're going to have plus 3m. Then here we're going to have 3m squared
Can I just give you the values?
3m squared. Okay, it's fine. Let me just rewrite it, but yeah. Okay, you can give me the value, then it's okay.
M I got 1.
Okay, let me just erase here so that okay. Okay, the first M, we know that is M equals to 1.
-1
Minus 1.
and -2.
Okay, minus 2. All right. So which means M minus 1, M plus 1, and M plus 2 equals to 0. Then it's fine. Then after that, when we have this, it means that now for these values that we just worked here, our complementary function, which we can call it x CF of t, is going to be equals to C1 e to the power 2. You can start with anyone there. We have, you can say C1 e to the power 2, not 2. Let me start with this one. The way we must do it exactly the way we wrote here is our M1, M2 is going to be C1 m to the power t, and then plus C2 e to the power negative t, plus C3 e to the power negative 2t. Then when you have these ones this way, now we are done writing this one here. Then we will have to find the particular equation. In order to find the particular equation, we're going to divide in our equation. We have this equation here. For our x2, we're gonna divide everything by this, everything we got by this one here, so that we can have x2 only aside. So when we divide that, then our particular equation is going to be x of IP of t. You write 40 minus 2. You divide by that equation, which is the same as you can just substitute d here. Then you're gonna be d minus 1, d plus 1, and d plus 2. So when you make that division, when you make this division, you will see that in this equation, okay, let me check something. Okay, the simplest method to use, we can use this method of, because I think there is a simple method that I am thinking of, which we can use there. So the other thing that you must remember is that when we say 1 over d, we are making an inverse. So when we say d, we differentiate. If I say d of 240, you know that the answer is going to be 4. But when we say 1 over d, like this way of, let's say 40, then we know that the answer here is supposed to have t squared. But when it have t squared, you find that when you differentiate this, it becomes 4t. So which means there must be 2 here to be 2t squared. So the same applies to this method that we're going to be using here. So let me just erase this part. Okay, let me just erase. Then so if I start with a d, I'm gonna write as 1 over d plus 1, d minus 1, and d plus 2. This is of 40 minus 2. So what will happen here, you will see that if I differentiate, if I only reduce this to be 1 over d minus 1 into d plus 2, then I will first the first one here is like I'm going to be working as 1 over d plus 1 of the equation of 4t minus 2. Then which means this one here I'm going to be when I reverse it back, you will see that is the same as this one here is d plus 1. So it won't be like I can divide. Let me divide this equation by d everywhere. If I divide by d, I will have 1 over d divided by 1 plus 1 over d. And it won't give me anything there. I want something more. I have to find a way. Let me see what I can do in order to make it more clear. Okay, it's fine. Let's start by, I want to test this method if it's gonna work properly. But I think it's going to work. This one is gonna take my time. So based on the equation there, for x2, we have minus d cubic plus minus 2d squared plus d plus 2 of x1 equals to 40 minus 2. So now we already got the complementary equation is fine. We have to get a particular equation. So in order for us to get a particular equation, we are going to say our y is going to be equals to 40. Instead of 40, we are not going to say 40. We are going to use an alphabet, A and B. We're going to say our y equals to 4 A plus B, or A plus B. Then which means our y prime is going to be equals to 4. Then our y second prime is going to be 0. And our y third prime is still going to be equals to 0. Then we're going to substitute this value there. So where there is y prime is going to be 0 minus 2, where the second one is going to be also 0, plus where there is going to be 4 plus 2 in brackets 4a plus b. So we know that this is going to be equals to 4t minus 2. So now we're going to be left with 4 plus 8a plus 2b, which is equals to 40 minus 2. Then, oh, sorry. Yeah, I made, there is something that I was supposed to do there. Remember, it's not supposed to say 4a, it's supposed to say 4t. So when you say 4t, then when we differentiate here, it will be saying, it will say 480 is gonna say y prime is going to say 4a. Then here is gonna be 0. Let me check if now there is something that I'm missing here. Let me rewrite this properly for ax plus. Our y is going to be equals to a t plus b. Yeah, this is fine. Y dot is going to be equals to a, and then y dot equals to 0, and y dot equals to 0 again. Yeah. So now when we substitute, here is going to be 0 plus minus 0 plus is number 2 is going to be, I'm gonna erase this part so that I don't make a mistake. So if we check here in our equation, we're going to have 0 is 0 minus 0 plus, for D1 is this one is going to be a plus 2 in brackets 2 is going to be 80 minus plus 4 plus b. Then this one is going to be a plus 2 80 plus 2b. So now if you check, we're going to have equation says 280 equals to 4t. Then we got divided by 2t. Our a is going to be, because we got divided by 2t, our a is going to be equals to 2. Then we also have another equation which says A, this A plus 2B equals to minus 2, is minus 2 there. Then we substitute 2 here in A, we're going to have 2B equals to minus 2 minus what? This 2, when it goes that side, is going to be minus 2, which is going to give us minus 4. Then if we divide by 2, our B is going to be equals to minus what? Minus 2. Then in our original equation, our Y was equals to, our BA is 2. Our Y equation there is AT plus B. Our A is 2T minus 2. So this is our equation. So this equation that we got here, our Y, is YIP of that T is equals to 2T minus 2. So we got the particular equation. So if you check in your book there, do you check in your memo?
I'm checking.
If you check in your memo, they did the hard way. I showed you how to do it. Do you see that we got the same answer as 2T minus 2 for IP, for X? Actually, the only difference I did there, you can just change this Y. Instead of using Y here, we can make it to be X. X1, we write X1. The method is still the same. It's X1 here of IP. Even here, you write the X. Even this idea where I wrote Y here, you just erase. Instead of using Y, we're gonna use, let me just change to X. We use X, you use X here. X of 1 equals to that X dot 1 and X dot and X dot. So the answer final there, I'm using the difference method. The answer there, if you check, is the same.
They continue from there.
Yes, we are not yet done. I'm just showing you that the answer for particular equation, which is 2T minus 1. So you must use this method that I'm showing you. And then now we have a particular equation. When we have a particular equation, then our solution, we only manage to get the solution for X1. Our X1 equals to XCF plus XIP. So which is going to be XCF. Our XCF is going to be equals to, C1 e to the power T. The way we wrote it in we started with e to the power 1 plus C, 2 e to the power positive T plus C3 e to the power 2T. Then for IP is plus 2T minus 2. So this is our X1. So we only get the value of X1. Then we also have to get the value of X2. So in order for us to get the value of X2, we can substitute this solution that we get in equation 1 of the equation, is either in equation 1 or in equation 2 or in equation 3 or equation 4. Then we can choose to substitute this equation in equation 3, the solution of X1 in equation 3. So if we substitute this equation in equation 3, we are going to get X2. So in order for us to do that, you will see that if we write our equation, the first equation that we have for equation 1, it says d squared plus 1 of equation of X1 plus 2 minus 2D minus 2d of x2 equals to 2t. So which means our 2d of x2 is going to be equals to 2t. This one here is going to be minus, which means it's going to be 2t. Instead of starting with 2t, we can just start with this one, which was going to be, which is going to change to d squared plus 1 of x1 minus 2t. Then now when you substitute this equation, I'm going to do it here. I'm going to try to first do it there. So now when we substitute that equation, you will see that in your equation there, you can even divide by, we can start by dividing by 2, or you can divide by 2 later, not now. Then you will see that if you divide it by 2, let's just divide by 2, so that we'll follow the instructions. Our dx2 is going to be 1 over 2 in brackets d squared plus 1 of x1 minus is going to be t. So now when we have divided by 2 that, then we can now substitute the equation. We will substitute the equation of x1, this equation, in where there is x1 here. So I'm going to delete this. Then when we substitute that equation, we're going to have 1 over 2 of d squared plus 1 of the equation that we are substituting is going to be c1 e to the power negative t plus c2 e to the power t plus c3 e to the power 2t. And then we also have minus t. Then this is going to be equals to, remember this is equals to d of x2. Then when we do this, we can first multiply, we can first maybe divide by 1 over 2, is up to you. But, or you can first differentiate, not differentiate. If we first differentiate, I'm going to first differentiate everything. If I differentiate this one 2 times, it's going to be negative and it's going to be positive again. I'm going to have c1 e to the power negative t. And if I differentiate this one 2 times, it's going to be plus again c2 e to the power t. But if I differentiate this one 2 times, it's going to be 4. It's going to be 2t, 2 and 2 is going to be plus 4. c3 e to the power 2t. Then this one here, we're going to take it, we're going to deal with it later. We are not dealing with it now. We are dealing with only this part. So now I'm going to add everything multiplied by 1. It's going to be plus c1 e to the power negative. And one more thing, remember, I think we didn't substitute everything there because our t, our x1 is equals to, it's not exactly this. So let me erase here. I didn't substitute everything. I only substituted the equation, only one equation. So I'm going to erase here. And I'm going to also erase, let me just erase, everything is fine. Then the particular x1, our x1, you know that is going to be equals to c1 e to the power negative t plus c2 e to the power t plus c3 e to the power 2t. And we also have plus 2t minus 2. This is our complete x1. And we also have minus t here. Then now we can start our differentiation. Remember, this is going to be 1/2. You can brackets. Then everything we are going to differentiate 2 times is going to be C1 e to the power negative t, and then plus C2 e to the power t, plus 4 C3 e to the power 2t. This one, when we differentiate 2 times, is going to be 2, then it's going to be 0. Then we can just leave it as it is there. It's going to be 0. Then we're going to add 1 times everything there. It's going to be plus again, because it's plus sign there, C1 e to the power negative t, plus C2 e to the power t, plus C3 e to the power 2t, plus 2t minus 2 minus t. So we divide, we can add the first thing that we can do so that you can have a good answer. First, add the like terms. You have this one and this one here. They are like terms. There are 2. It's going to be 2 C1 e to the power negative t. You also have C2 or t, and also this C2 here. You're going to have plus 2 again e to the power C2 e to the power t. We also have 4, this one. And we also have for C3, we also have this one here. It's going to be plus 5 is 5 C3 e to the power 2t. And we also have plus 2 t minus 2, all brackets minus t. Then we divide everything by 1/2. Then we're going to get C1 e to the power negative t plus C2 e to the power t plus 5/2 C3 e to the power 2t and plus t plus t minus 1. So now we have this minus here, which means minus plus t minus t. We know that is going to give us 0. Then we can just erase this t. Then we're going to be left with minus 1. So remember, this is our d of x1, x2. So in order to continue with this equation, then our x2 is going to be equals to 1/d of C1 e to the power negative t plus C2 e to the power t plus 5/2 e to the power 2t minus 1. So now we are going to take back how this equation was. Before we integrate this, it's like this one is differentiated, which means before we differentiated it, this equation was negative C1 e to the power negative t, this one only. Before this one was differentiated, it was still the same. It was C2 e to the power t. But before this one here, we can see that we have 2t here on top. Before this one was differentiated, if we write 2t like this, we know that here is going to come down as 2. So it means that here we were having 10/4. 10/2. So if I have a 10/2 like this way, if I differentiate this one here, it's going to say 2. No, not 10. It won't work 10. Let's say we were having 5/4. I'm going to write 5/4. I'm going to explain now why I'm writing 5/4. 5/4. If I differentiate this one here, it's going to say 2, which is going to say 10/4. And 10/4 is going to remain, if we divide by 2, is going to get us back to 5/2. So plus, then we just differentiate it. This one, before it was differentiated, it was just minus t. Then our x2, we just found our x2. Then our x2, we just found it. Then now when we have found x2, then we are done with our solutions. We have x2, we have solved, and also we have x3, x1, the first one, x1. Our x1 is this, remember? We already done it, just that you have to watch the video. So do you have any question?
No.
Okay, so are you fine with question 2? Ne? So
Yes.
which means you can just watch the video again, then you copy exactly how I did it. So don't copy those 1 for 1 over d plus 2d minus 1 because of, I mean in your memo there, because you don't know how to get that. So copy exactly the way I've shown you, how you work it out until you get that answer for 2t minus 2. Then you can just watch this video, then you copy it exactly the way we're doing it today. So do we have any question again which I need to explain in this question paper?
Yes. Question 1. I don't
Question
think
1.
we didn't finish it.
Question 1, okay. Let me check question 1. Okay, I'm gonna erase here. So for question 1,
I'll send you my answers for question 1 that you did.
okay, no problem. Okay, I'm gonna be waiting. Let me know when you are done sending. Yes, I think we did question number 1, if I'm not mistaken. Is a triangular. Okay, are you done sending?
I sent it.
Okay, no problem. Let me check.
I copied those answers from the lesson.
Okay, no problem. All right, let me just go through it. Okay, d minus 2 over d is fine. Yeah, okay. Exactly how you did it is perfect. So I don't have any problem. I was just reading all the steps that you did. Everything is perfect. So the way you have written it is perfect for question 1. So question 1, you can copy exactly the way we did it before. There is no problem at all. Then question 2 is fine. Just recheck maybe the other question that we think maybe we can check it again.
So question 1 is completely fine.
Yes, it's exactly the same. So the only at the last step, ne? Your answers, I checked even your answers, everything, it must end as this way. You must rewrite, you wrote everything fine, but at the end when you write it this way. You must have this, you must just rewrite it as in this format. Everything is fine. All the steps that we did, there is no problem. You must just add it to be equals to this in a nice way.
Isn't there a second part to question one?
Which one?
Question one.
Question one. Let me. Okay, the first part, let me just, maybe I'm not opening. Okay, let me recheck your answer. Okay, the first part, okay, the first one, the first part you got 2 plus 2, or d plus, okay, it's fine. Then after that you get 6, you got the 6, you have this part whereby you have 6 minus 12. E to the power. Okay, let me just recheck properly this question because I just checked your steps. I didn't read the. Okay, so that this system is equivalent to both the following triangular system. So the first one, did you get this one in your question when you are doing it?
Yes, I only think I did that.
Okay, because here when I check, I see you. Okay, let me just recheck again. Yes. Perfect. I see that. Yeah, now I see properly. You did this part here. So there is also this one here for this
Yes, I
idea.
never do that.
You didn't do this one. Eh? Okay, it's fine. Let me do it with you now. So the equation we have is the other one is 2D minus 3. So this is equation 2. So in order for us to get to the second one, what needs to be done? We are going to multiply multiply by just give me 1 minute. So the first thing, remember in this equation, when we are doing it, we want to be left with only x. So we have to eliminate these two, this d, and this d. So the first thing that we're going to do, we're going to take equation 2, we subtract by 2, equation 1. So that here it can say 2d. So when we do that, if we say 2d, this 2 minus equation 2 minus 2d is going to give us 0. Then if we say minus 3 minus, and we multiply this one, minus 3 minus 4, minus 3 plus 4 is going to give us 1, which is going to give us only, we're going to be left with x. And because this is this x is, when we working with them, it's like it's x of t. We're going to be left with x of t, then plus, then when you say plus, here if we take this equation, it's going to be 3d minus 3d minus 4 is going to be minus d, which is we're gonna change it to minus here. It's gonna be minus d, and then this one here is gonna be, when it's minus d, then minus 1 minus is, there is nothing there, so it's gonna be minus 1. Whereby if I put a bracket here, this one is going to be plus, so that is going to say negative d minus 1. Then this side is gonna be for y, which is equals to 0 minus everything there is going to give us, multiply by 2 is going to give us minus 4 plus 8 e to the power 2t. We multiply everything by 2. We say 0 minus everything multiplied by 2. We are still using this equation. Then we're going to get this, that equation there. So when we get this, we have now x of t, which is equals to minus 4 plus 8. Then if we write x of t in the form of x of t, our x of t, we shift this one the other side, we're going to have x of t, which is equals to d plus 1 of y minus 4 plus 8 e to the power 2t. Then now we have that x of t. So in our x of t, you will see that now in order for us to, you will see that now we have this x of t. We can substitute x of t in equation 1. When we substitute x of t, we are going to substitute everything the same way we did the first time. When we substitute this x of t in equation 1, our equation 1 is this one here. It means that we are going to have d minus 2 and also d plus 1 of y plus 2d of y is going to be equals to, and remember when we substitute that of y, because we are substituting everything there, I didn't add all the values. We here is going to say, we can put a bracket to indicate that everything is going to be multiplied by d minus 2. Then it's d minus 1 minus 4 plus 8 e to the power 2t. Then plus, we have plus 2d of y, which is equals to 2 minus 4 e to the power 2t. Then now when we have that, we can multiply everything. We can multiply these two values there. When we multiply these two values, it's going to give us d. D times d is going to be d squared. D times this one is going to be d. And then d minus is going to give us minus d minus 2. This is the side of y. Then we differentiate this. If you differentiate it, 0. And then this one, if you differentiate it, is going to be plus 16. 16 e to the power 2t. And then minus this one times this one is going to be minus, it's going to be plus 8 minus 8 e 2t plus 2d of y, which is equals to 2 minus 4 e2t. So now we're going to be having, if you summarize properly, you're gonna see that we have you will see that we have, we're going to just add them. We have, if you add here, we're gonna add this like terms and this one here. Here we have d plus, if you check that, if we add it here, we're gonna end up having d squared plus, because it's 2 there, plus d minus 2. This is for side of y. Then which is equals to, we take all these terms, the other side is 2 minus 4 e2t. Then 16 plus this one here, 16 plus this one is going to be 8, which is going to be minus 8. 16 plus, okay, let me check. 16 plus this one is minus, it's going to be 8 minus 8e 2t. This one is 8, it's going to go the other side, is going to be minus 8 again. Then the answer that we're going to be left with is d squared plus d minus 2 of y, which is equals to minus 6 minus 12 e to the power negative, not negative 2d, 2t. So now we have solved the minus 6 minus 12, plus minus 8 here is going to be minus 12. Okay, it's fine. So there is something that I'm just checking. I'm not sure what I did wrong. Okay, so we got minus 6. The first one we got, let me check. The first one is fine. We got minus 8, minus 4 plus 8 is fine, is correct. Then the second one, this one here, we did everything right. I think, let me check it. D squared, okay, d times this is d squared. This one is d minus 2. Okay, minus 2 is gonna be 1. Minus is fine then. Then this one here is gonna be 0. Yes, yes, yes. This one times 1 is gonna be plus 8. Okay, this one times this one. This one times this one is gonna be 0. This one times this one, when you differentiate it, 16 2t plus 16 2t is right. Then this one times 2 times this one is going to be 8 is right. Then minus 2 times 8 here is going to be minus 16. You see that it's going to be minus 16. So this 16 is going to cancel with this one. So when this 16 cancel with this one, we are going to be left with 8 here. So which means here is going to be 2 minus 4. This 8 is not there. That's the problem that we did there. So this 8 won't be there. It's going to be minus 8 only. So when it's minus 8, then our answer will be minus 6 minus 4. So now we are done. This is correct. So you can just rewrite is d the way it is there, and x you just recopying back. D plus 1, already solved this one, of y. equals to minus 4 plus 8 E2T. Then this is correct. So let me just browse back. You can see there, you can see. Do you have any question?
No.
All right. So this is correct. You can check any other ones because I want you to submit. Okay, if you
Is it finished? Is question 1 finished?
Yes, we are done. Yes. Remember, this is part 2. The part 1 you did it already. The ones you wrote there. So question 1 is finished. Question 2 we did it. Question 3 also we did that. So I think you just have to combine your work. Maybe before you submit it, you can just show me the final your final answers after combining everything.